When we think of the sun, we imagine an enormous ball of burning gas, so huge that 1.3 million Earths could fit inside it. That's already a mind-expanding idea. Yet, in the vast theater of the cosmos, the sun is merely a dwarf, a modest star by cosmic standards. Now let's venture into a realm of sheer astronomical enormity, the realm of Scuti, one of the largest stars ever discovered. Compared to Scuti, the sun becomes almost an invisible speck. But how big is Scuti? Let's begin an awe-inspiring journey to grasp this scale. If the sun were hollow, which it's not, imagine stacking Earths inside it until no more would fit. 1 million Earths would nestle inside like marbles in a vast glass sphere, and there'd still be room left over. Yet in stellar terms, the sun is classified as a G-type main sequence star, G-dwarf. Not particularly massive or giant, just average. In the cosmic hierarchy, there are several classes of stars. Red dwarfs are smaller than the sun. Yellow dwarfs, like our sun, are considered medium-sized. Then we have giants and supergiants, which are much larger. And finally, there are hypergiants, the true titans of the universe. The sun, for all its splendor, barely registers among the giants. Scuti earned fame in 2012 to 2013, when astronomers calculated its potential maximum radius, making it possibly the largest known star by radius. If you replace the sun with Scuti in the solar system, it would engulf Mercury, Venus, Earth, Mars, Jupiter, and Saturn. Only Uranus and Neptune would orbit beyond its surface. That's not just big, it's staggeringly vast. 13 quadrillion Earths could fit inside Scuti. Yes, that's 13,000 trillion Earths. If the sun were a basketball, Earth would be a small bead. Now, if Scuti were scaled down to the size of a soccer stadium, Earth would shrink to a grain of sand, too small to see with the naked eye. In other words, just crossing the surface of Scuti would be comparable to an international flight. For light itself, Scuti began as a massive blue star burning hydrogen at a frenzied pace. As it aged, it expanded and cooled, transforming into the red hypergiant we see today. Massive stars like Scuti live fast and die young. Their lifespan is just a few million years compared to the sun's 10 billion year life. In the future, Scuti is likely to explode in a supernova. The atoms forged inside Scuti, including carbon, oxygen, and iron, will eventually seed new stars, planets, and potentially life. We are made of star stuff, as Carl Sagan famously said. Scuti forces scientists to reconsider the limits of how big stars can become. It challenges models of stellar formation and evolution. When we compare Earth and even the sun to Scuti, we gain a humbling perspective. Our world is precious, but it's a speck in the grandeur of the cosmos. Studying hypergiants like Scuti improves models of supernovae. It aids our understanding of black hole formation, and it reminds humanity of our insatiable drive to explore the unknown. Stars like Stephenson 218, Westerland 126, and WOHG 64 may be larger, depending on how we measure size, whether by volume, mass, or radius. So while Scuti holds the title for now, the crown may pass to another giant as data improves. In a universe of 2 trillion galaxies, each containing billions of stars, Scuti is a reminder of the cosmos's unimaginable scale. When we say 13 million Earths fit inside the sun, it's awe-inspiring. But when we realize that 13 quadrillion Earths could fit inside Scuti, the mind almost refuses to grasp it. Yet, it's real. The study of such stars doesn't just teach us astronomy, it gives us a cosmic perspective, one that blends humility, curiosity, and wonder. As long as we look up at the stars and ask how big, how far, how ancient, the legacy of Scuti and humanity's quest to understand the cosmos will continue.